Good morning, this is Kasturi Day. Today I'm going to start a new chapter on physics chapter according to ICSE syllabus class 8. It is the sound chapter. Okay, today I'm going to start. So, first we start with the introduction. So, the sound is a wave, okay? It travels in the form of wave. It's an energy which travels in the form of wave. So the wave in which the particles of the medium, uh, I'm sorry, it is the form of energy which produces the sensation of hearing. Okay, the sound is a form of energy which produces the sensation of hearing. It is produced due to the vibration of a body. It needs a medium of propagation like solid, liquid and gas. In vacuum, the sound cannot travel. So it needs a medium for propagation. Then sound is maximum in solids and it is less in liquids and least in the gases. See, when a body vibrates, the molecules of the medium also starts vibrating. The kinetic energy of molecules, they change into potential energy and potential energy into kinetic energy during vibrations. So during the vibration, when the vibration is going on, when there is vibration in the medium, then what happens? The kinetic energy changes to potential energy to kinetic energy. This goes on in the till the vibrations are there. So sound is a form of energy. Then when a source of sound vibrates, a periodic disturbance is created in the medium near it. Okay. So when a source of sound, like when we beat a drum, the air near the drum, surrounding the drum or near the drum, that there is some disturbance is created in that air. Okay. So this travels in the medium in the form of waves, and due to this the particles of the medium vibrates about their mean. That is, the particles here in this case, we'll give an example, that is that when we beat a drum, so the particles near the drum, that is the air particles, they start vibrating about position, and therefore to transfer the energy with a constant speed from one place to the other, of the medium to the other places. For example, if a vertical metal strip is taken with its lower end fixed, its upper end is pushed side and then released, it moves alternately to and fro. It's moving from right to left, left to right, like this, when sound is produced. Now one complete to and fro motion of the strip forms one compression and one rarefaction, which together constitute one wave. So when there is a to and fro motion of this metal strip, then there will be, in one complete to and fro motion, there will be one compression and one rarefaction, and that constitute a wave. Okay, now the wave in which the particles of the medium vibrate about their mean position in the direction of the propagation of the sound, that is, in which the sound is propagating, the direction in which the sound is propagating, that is known as longitudinal wave. Okay. Now the sound travels in the air in the form of longitudinal waves. Okay, it travels in the form of longitudinal waves, and the sound travels in strings and transverse waves. In strings, when the sound travels, that is in the form of transverse waves. But otherwise, when it is in other mediums, then it is in the form of longitudinal waves. Now, if the particles of the medium vibrate, vibrate normal to the direction of the propagation of wave, then the wave is a transverse wave. So, longitudinal wave is in the direction of the wave, and if it is perpendicular to the direction of the sound, then it is the transverse wave. Okay, so see the picture. This first one is the longitudinal wave, when the gap of the lines which are very close to each other, that is the compression, and the lines which are away, which are further apart, that is rarefaction. So one complete compression and one rarefaction together forms a wave. Okay. So, and in the first picture, there is a metal strip which is vibrating, okay, which produces a sound. It moves from A to B. Is the O is the mean position. From A to B, it vibrates to and fro. Now, in the second picture, the transverse wave, there is crest and troughs. See, the wave is traveling perpendicular to the direction of the travel. Okay, so there will be ups and downs like a wave of the sea we have seen, no, like that. There is crest, the upper wave, that means upper hill is known as crest and the downhill is known as the trough. So like that, where one wave will be one crest and one trough. Okay, this is the transverse wave. Okay, next is terms related to the sound wave. First is vibration. Vibration is the to and fro motion of a prong of a tuning fork about its mean position is known as one vibration. Okay. Then amplitude, the maximum displacement of a vibrating body from its mean position is known as amplitude. It is denoted by an SI unit, which is meter, and the larger the amplitude, the more is the loudness. It is denoted by A, small a, okay, and SI unit is meter, and larger the amplitude, the more is the loudness. That is, this sound is directly proportional to amplitude. Okay, then see, loudness is directly proportional to amplitude. See, this is amplitude, the maximum displacement of the wave from its mean position. Okay, then we come to frequency, the number of vibrations produced by a number of vibrations which is produced by a vibrating body in 1 second, that is known as frequency. In 1 second, the vibrating body, the number of vibrations it is producing, that is known as frequency. Okay, it is denoted by small f, and SI unit is per second, or you can say hertz, Hz. Therefore, when a vibrating body produces one vibration in 1 second, then its frequency is said to be 1 hertz. Bigger units of this frequency is kilohertz and megahertz. So kilohertz is 1 kilohertz is equal to 1000 hertz, and 1 megahertz is equal to 10 lakh hertz. Okay, frequency does not depend on the amplitude of the vibration or the nature of the medium through which the wave propagates. Okay, it does not depend on the amplitude of the vibration or the nature of the medium through which it propagates, the wave propagates. Okay, see, frequency, high frequency wave, the number of crest and troughs will increase. Okay, but in case of this low frequency, the crest and troughs will be lesser amount. Okay, now the time period, the time in which a vibrating body completes one vibration is known as time period. It is denoted by capital T, and SI unit is second. See, between two crests or two troughs, that will be the time, that will be the time period. So if T is equal to the time period of the wave, then by definition it is the relation between the this deduction is the relation between the time period and frequency. So if T, capital T, is equal to the time period of the wave, then by definition in time T the number of waves will be equal to 1. Therefore in 1 second the number of waves, that is frequency, that will be equal to F is equal to 1 by capital T, or you can say frequency is equal to 1 by time period, or time period is equal to 1 by frequency. Okay, now we come to wavelength. Say, the distance traveled by a wave in one time period or vibration of a particle of the medium is known as its wavelength. Okay, it is denoted by lambda. Okay, This sign, this y inverted y sign, that is known as lambda. And SI unit is meter. It depends on the nature of the medium through which the wave is traveling. Okay, in longitudinal wave, the distance between two consecutive compressions or between two consecutive rarefaction is known as one wavelength, or you can say between two troughs or two crests will be one lambda. Okay. Now, do all vibrations produce sound? It has been proved that human ear is not sensitive to vibration of all frequencies. We cannot hear all the vibrations. Okay, so all frequencies are not audible to human beings. If the frequency of the vibration is less than 20 hertz, then it is known as subsonic vibration or infrasonic vibrations, which are not perceived by the humans. Okay, which the humans cannot hear. Then if the frequency of the vibration is between 20 hertz and 20,000 hertz, that is known as sonic vibrations or sound vibrations, which is audible to the human ears. Okay. Higher the frequency, the sharper or the shriller will be the vibrations with the effect of the sound on the ears. Okay. Now, if the frequency of the vibration is more than 20,000 hertz, then it is known as ultrasonic vibrations or ultrasonics. Okay. This type of vibrations is also not audible to the human ears. Okay, infrasonic vibrations are audible to animals, some animals like elephants, some dogs, etc. And these ultrasonic vibrations, ultrasounds you can say, these are audible to some bats. Okay, and the human audible range is from 20 hertz to 20,000 hertz. Okay, so I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. Hope you are liking the videos. Press the like button, and if you have any doubt, you can also write in my email ID, that is kasturi74@gmail.com. You can also contact me in my Facebook account. Okay, and please do subscribe to get the notification of my next video. And also I will get some enthusiasm to produce you some more interesting videos for you. So please do subscribe and wait for my new website, which will be launched very soon. Okay, that will contain information of your and other subjects also, and some interesting facts will also be there. Some surprises will also be there for you. So please go wait for that. Thank you.